Okay, hello everyone. Welcome to this talk of Percona Live Online, the low-hanging fruits of MySQL. My name is Kedar Vaijanapurkar. I am presently working at Percona as a MySQL DBA in Tier 2 team. I have like 15 years of experience. I live in Vadodara, India. I'm one of the eventual DBA who turned into MySQL from the programming background. I enjoy spending time with family. There is a little picture of ours. Um, I also like listening to music, taking photos, playing chess, cricket, and also blogging. Okay, let's quickly move to the agenda. What are we going to do today? We are going to understand the low-hanging fruits. What is it? How low that is, and what is beneficial? How it is beneficial to us. Then we will talk about the things we should consider before we decide to pluck the low-hanging fruits. And while we will identify the low-hanging fruits in MySQL, we'll look to get the quick tips about them and fixtures that I usually about it. Uh, and towards that, we'll have some conclusions to make. So, low hanging fruits. What are they? The common understanding of low hanging fruit term is something that is easily achieved with minimal efforts and possibly low risk. This talk about the low hanging fruits of MySQL aims to point you towards the important aspects of the database improvements that are into common knowledge, which are proven to work in most cases, and some of the basic things that you should check, or something that I usually check when I'm going to I'm looking about improving the database performances. Um, Moving ahead, before plucking. So what is something that we should definitely consider before implementing or before deciding on the things that we are going to talk in this talk? So to start with an example, that we all know that disabling binary logging saves up some space, right? It will save some space and save some additional IO that requires. So should we do that in all the environment that we have? So this is something that is a low hanging fruit, where disabling binary log will save up some space and IO, but that is not really identical or say ideal for all the environments. Like for example, if we need your replica to be a candidate master, then disabling binary logging is not a good idea there. If we have idea of having additional replica underneath those particular slaves that are there, then also that's not a good idea to disable the binary logging. So like we have a solution here, but the very ambiguous answer in the consulting world is it depends, right? As annoying as it may sound, it is true. If something works for client X, it is not guaranteed solution for problem the same problem in client Y, right? So before using any trick in production, DBA should weigh in well with respect to their environment. They should test it and then go ahead and look if they want to that is a good fit or not. Nothing is low unless you know. Even though I name this talk as a low hanging fruit, I'm not saying that it's going to be easy. It's not going to be solving all your problems. The points we discuss here are surely of very important, and something that I do check during the usual reviews of the environment that we have. But production is not for trial and error. So take the points that we discuss here as a guideline, test them well, and follow it on. All right, so identifying the low-hanging fruits. Where are we going to find them? We'll start from the configurations, system and database level, where we are hosting the MySQL server. We'll talk about the database design, executing the queries, indexing strategies, or some of the tips about indexing, and we also talk about replication. We'll also look at the few points on backups. We'll look at the Swiss Army knife kind of tools that we database consultants keep handy. And finally, we will have a few points on the cloud environment that we should keep in mind. Note that we have included the links for additional information in these slides. So we are not going to discuss everything in depth because we are covering a lot of points here. So if you need to go and dig deeper in that particular points, I have links included. Please go ahead and explore them. Do not hesitate to reach out to me for any further explanation. Okay, let's start with MySQL configuration, the famous mirror CNF file. If you ask the single most powerful variable to tune in your database environment, it will be IODB buffer pool size. What is IODB buffer pool size? It is the memory space holding the in-memory data structures of IODB, like buffers, caches, indexes, um, raw data. So ideally, we allocate 75 to 80% of system memory to the dedicated database server, right? Uh, Consider the word dedicated. If database instance is sharing the server with the application or something else, be careful while you're allocating the memory. Next one is actually related to the related variable, which is IODB buffer pool instances. What it does is it mentions the number of instances or say chunks of the buffer pool that we are going to make. So buffer pool access also takes a mutex, and if we have high concurrency, sometimes this can become a bottleneck. Like every every connection is trying to access buffer pool. So documenters suggest that we have up to one buffer pool chunk of at least 1 GB in size, but um, you need to verify whether whatever configuration you are having right now is really causing any kind of contention. How are you going to do that? Well, the engine IODB status, you should look for the mutex around buff or buff.c, and if you're looking that if that is something that you can take as a hint that your buffer pool instances are not sufficient, so you can consider increasing them. There's a link associated here with the refer word. You can click on that and go ahead and explore the details that are there. Next is RBflush method. This variable defines the way we open the database files and logs. Most common method or say option that works for us is ODirect. ODirect is a flag that is passed when a file is opened. It instructs to bypass the page cache and perform any IO operation directly against the storage. It is not going through the page cache or kernel scheduling for write back operation on the disk, etc. uh, go ahead and refer to the link for details there. IODB, so the suggestion here was like use ODirect for RBflush method. IODB log file size. This variable defines the reader log size. The reader logs are the disk-based data structures that are used during the crash recovery to correct the data written by incomplete transaction that are because incomplete transaction that caused by the crashes. Now, IODB flushes the modified data pages which are there in the buffer pool to disk in a small batches, and this process is known as checkpointing. The logs by default are like by default they are two logs, and they are circular in fashion, like they are written circular in fashion. So one log completes it flushes that and then start writing on the second one. So the checkpointing is done when every time these logs are rotated. So the log one is rotated, the checkpointing is pressed for writing those contents to the disk while the other log is getting filled. So if the log is small, the checkpointing is pressed to write that logs to the disk really fast. Uh, if we have a larger amount, larger size allocated to the IODB log file size is going to improve the performance. Now there are conflicting information in the documentation, if we might have read that making the reader log larger will cause the log recovery slower, but then there is another information that says that there has been improved uh, code for the log recovery section, where you can make the log IODB reader log large enough the way you want, even as large as the buffer pool size, and it will not really cause much of a harm to your server startup. I would consider increasing the IODB log file size as large as the largest hourly traffic. So if you are getting like this is something you can figure out from your monitoring, what is that value, but do not hesitate to increase the IODB log file size to help improving your IO performances. Next is IODB log buffer size. This is a buffer used to store the logs in memory for the transaction before you has that has to be written to disk. So if you have large transaction doing a lot of insert, update, delete, consider increasing the IODB log file size. Sorry, IODB log buffer size. Uh, Next is IODB read and write IO threads. As the name suggests, these are the threads that IODB use for performing internal reads and write operations. So if you see pending read in your IODB engine IODB status, so you're going to get these kind of hints in the engine IODB status. So go ahead and explore what is engine IODB status command, and there is a documentation page for that. And you can increase if you see the pending read in pending reads in IODB as a hint to improve these variables. um, okay, so query cache is something I have included here. It has been a common knowledge that uh, mostly query cache is not really helping, and it's an overhead. uh, it is a case sensitive cache storing your query results, and if the query having poor indexing, uh, then I mean, if you have a proper indexing, then query cache is not really important. There is a reason why query cache is removed in 8.0, because if you have optimized queries, query cache is an additional headache for the optimizer to go ahead and verify every time a query is fired whether it is there in the cache or not. So you can check your query cache performance using external cache performance using the uh, monitoring methods, but it is better to look for external caching mechanism. Next is log output. By default, this variable is file, though it is good to verify that you do not have it changed it to the database, or say storing your logs inside database, in table. So log output defines the output location for general and slow query logs, and it is best to store logs outside database. Table cache. Table cache. Okay, table cache is in a multi-threaded MySQL system. When a client issues multiple queries in parallel, pointing to the same table, or uh, when the query is pointing to the same table, the table is open independently for each session. Like if 10 queries are pointing to one table, they will all have individual table handler to access that particular table. So this file opening operation creates some or incurs some costs to improve on the performance. And to improve this, we have a table cache. So if we have like 10 queries using them, and then if any other request come in for the same table, and if the cache is already having the file handler for that particular table, the table cache is useful here. Of course, this requires sufficient open files configured on the system level. So the details are provided in the link that I have included here. So go ahead and explore the table cache and table definition cache based on the same concept. Refer the link there. Let us move ahead with the configuration on system level. Uh, Basically, MySQL writes two kind of things. Very broadly speaking, data and logs. An idea would be to provision individual mounts for those two, right? Like put data in one mount and logs in the other. So it also looks like a well-configured system. uh, so first is specify separate mounts for data and logs. Next is about swappiness. So swappiness defines the percent of free memory before activating the swapping activity, right? So lower the value of the swappiness, less likely it is less likely that your database will be database system will push towards the swapping, and the more memory, more pages would be kept in the memory. So swapping is bad for database, and we would love to have things in memory. So consider reducing it to one. Like we do not want to completely disable it. We need to have a little breathing room, but we don't want it to actually swap either. There's a link here. Please go ahead and refer it. Next point to consider is disk mount option. Now Linux maintains 3 timestamps for each of the file, that is modified time. change time and access time. We can check that using the stat command, like stat file name. You'll see these three options. But anyways, for like database files, like the data files that we are having, we don't really care whether we have the access time available there or not. And since files are accessed very frequently, that's causing additional IO, is better to disable this configuration uh, in the mount options. Okay, finally, I'm going to talk about the IO scheduler. They define the way Linux optimizes the disk requests and schedules their execution. IO scheduler can surely help improving the IO performance based on the traffic patterns, but most commonly, I have seen that no op IO operations IO scheduler works better. It is something that can be concluded by benchmarking, but I needed to mention it here. So no op is the way to go. Okay, a dedicated page for OOM. So what is OM? Out of memory situation, where system is pressed for memory, but it has left with none really. So like, why I have included a separate page? Because it is like combination of database as well as system configuration here. The solution here, that system ops, when there is, then when it goes out of memory, it looks for something to kill, like whatever is holding the highest memory, it will kill it and reclaim the memory from that process. So guess if you have MySQL running on a system, what what is who is likely to be the target here? uh, to avoid the out of memory kills, we should configure MySQL in the light of available memory. Like if you do not have a lot of memory, and like you have 64 gig and you're saying that okay, MySQL is free to use 100 gig, system is going to kill MySQL that way. So the let's understand, like MySQL has memory allocated in two major categories. One is the global buffers and the other is per thread buffers. Global buffers are allocated system wide. For example, IODB buffer pool, it is shared across the all the processes that come inside MySQL, like threads and all. And per thread buffers are like sort buffer. Like if the query is doing the sorting algorithm using the sorting algorithms, then the sort buffer is used for that particular thread. If you see that there are two queries I have used, that's a test box I have been using. I have calculated like estimated max available memory or max memory usage possible with 1000 connection and 500 connections. So present configuration says that I may end up using maximum of 16 gig of memory for 1000, or 8 gigabyte of memory for 500 connections. So if my system memory is say 4 gig, and if I'm configure it for like 500 connections, then I'm at high risk for getting MySQL killed out of memory. So how can we avoid this out of memory killed? Getting out of memory killed. There are a few things we can do. To start with, the first is max connections. So max connection is something that we should consider before uh, it should be a sane value, not something like just because you want to serve 2000 connections, you need to have a bulky system for that. As per current configuration, if you can only serve 500 connections, you should only have it as set as 500. You should also consider adjusting the per thread variables. And like if your queries are doing a lot of sorting, then consider improving those queries and then reduce the sort buffer accordingly. That way also you can extend your max connections limit. Something else we can do on the system, and it is based on how kernel makes out of memory kill decisions. So there is something called as out of memory score, OOM score, that defines the kernel, that defines the value that kernel refers to kill a process. Like let's say, okay, there's a sorted list of processes, and the top OM score person get killed, right? Process get killed. To save from that, there is another configuration set OOM score adjust, which adjusts the Linux kernel's out of memory scores for specific parameters. So if you have like OM score adjust of 1000, then it is most likely to get killed. If you set OM score adjust to minus 1000, it is actually going to disable the out of memory kill process. But if you disable that, it may end up freezing your system or even crashing it. So what we do, we usually adjust around minus 800, and that's something good enough value for the keeping MySQL from getting killed. That's definitely not mean it's not going to get killed, but it is going to delay it as far as we can say. The clue here is make sure you adjust your configuration accordingly. Okay, let's go ahead with the DB design. uh, so what are the low-hanging fruit ideas here? um, this time we will review the database design points, and let's see. So the first point is IODB tables. Use IODB tables if there is no specific use case for you to use any other engine. Use IODB. You know that, like, if you need to migrate to cloud environment, for example Aurora, it doesn't support MyISM. Even clustering solution like Galera, MySQL is a problem. MyISM tables are a problem, right? So consider using IODB engine. Next point says that create primary keys for your IODB tables. The reason behind this is IODB is a clustered index. I mean to say the whole table is stored in the form of a index organized structure. If you do not have a primary key, then you must use a normal unique key. But if neither of those are present in a table, then we have a problem. In absence of a primary key, IODB generates its internal row ID. uh, this process of generating internal row ID is not really scalable. Like at higher concurrency, we can observe the mutex contention for creating the row ID. So have primary key. The next is talking about a varchar primary key. If you have a varchar column defined as a primary key, it's not really a good idea, mainly because again it's a clustered index. It is reorganized every time the index is the primary key changes. And since varchar columns, if they are not sequential, there will be a restructuring of your index again and again. Next point is UUID as a primary key. Like it's been talked about a lot, and there are blogs in place, so do refer to that. When UUID begins with a timestamp known as the quasi-sequential, it's not really a bad idea to use UUID, but generally UUID is very similar to a varchar um, column, so it's not a good idea to use UUID that way. Finally, auto increment. Well, it's a common choice. So naturally occurring primary key, if it is not there, then go ahead and use an auto increment primary key, but have a primary key is the message. About integer types. When we create an integer type, by default, it is created as signed integer. And if you do not really want to store negative values, for which I have seen, like in majority of cases, if you are using integer columns, you do not really have need to use a negative values, so it is a wastage of storage. For example, a signed integer will can store 128 positive values and 127 negative values, 10. But if we make it unsigned, then it will allow you to store 255 values. So if you really do not need to store negative values, then it is a wastage of storage that way. The last point is about a line. I would like to say that text is not to store the text information. So this is something coming from my experience. Like the line is really stupid. The text is do not use text to use store the text. But what I mean to say here is, like, in my experience, I have seen like a tables having like 10 20 10 12 columns. One have a primary key, and then there are 11 text columns. The text, I mean to say text data types. These text data type columns are physically accessed. They causes additional IO and really are high on the storage requirement size. So text is just an example. The message here is use appropriate data type for your table definitions. Okay, we already talked about primary key, so let's not forget to talk about secondary keys too. What are secondary keys? They are indexes helping to improve the query performance other than primary key. Some quick tips would be to consider the cardinality of the column before you index them, right? Like if you have low cardinality, if you have a Boolean value, indexing them is not really going to help you every time you're going to include them. So do not index columns with low cardinality. Then do not include your primary key in the secondary indexes. Like IODB secondary indexes by default include primary key to the end of the leaf node. Like it refers to the primary key from where it fetches the data. So that's also a message that it is ideal to have a short primary key because it is appended in the backside of the secondary key, and that way it will reduce the short primary key will reduce the size being used by the um, indexes in total. Next is composite indexes. So composite indexes are like uh, multi-column indexes where they if you create the query when the query has multiple columns included in where clause, the composite indexes come handy. Like if you have name, then date, first name, last name, and date, then all the queries includes only name and name, last name, and date. All three query will be optimized using just one composite index, right? So if you specify column on the right order in the index, so single composite index can speed up several kind of queries in the same table. You don't need to index all the columns in a table. It's only going to use one of that. uh, uh, a covering index. Covering index is a special kind of index in the IODB where when covering index is in use, all the required fields for query are included in the index. So that's why it is called as covering, because if all the columns in select, in where, in order by, in group by, if they are there or they are covered by the index, there will not be additional disks, or it will not need to read the table actually to fetch the values. Data is directly fetched from the index. One quick note about indexing the dates. At the times you need to process data within specific date range, right? You don't really care to process the whole table, or if you're storing data from like a decade, what you need is only a week long of data. So you will have a range query there, like just process the where date range is last 1 week. An index on date columns comes handy in such cases. The one thing to remember is that when you have a range search done using an index, no further columns are used in that index. Like if you have, as I said, like your first name, last name, date, and then if you have like first name, date, and last name, and you have index used for first name and date, but then the last name will not be searched or scanned using the index, but it will be actually a table scan. So the idea here is, or message here is, put, if you're using a date column in a composite index, put it towards the end of the index. Okay, so now these are the basic tips about indexing. It's not really a primer. I have not even included examples. So there is very interesting link I have placed here for helping you in index design. Go ahead and check it out. But these are some points I definitely consider while you're reviewing the indexing. All right, next we'll talk about the querying. So what are the low-hanging fruits in querying the database? Well, do not use select star. Not saying do not use it, but if you do not need to read all the queries, you don't need to use star. Fetch specific queries columns only. This is going to reduce additional IO and network traffic requirements. Don't put your business logic in SQL. I see a lot of queries using like if else, and then cases, case structures. This is like a programming language. So put your logic in your code level and push only simple queries to the database. Like I have seen routines and stored procedure more than 400 to 500 lines, which really had complex business logic in there. Okay, next is an idea to use comments. So you can use comments, and it is a good idea to identify where that particular query is coming from, and that way it is easy to debug. Like this is very dirty query, but you know that it was proudly written by someone called Kedar, and you can pick that person up and teach him some query optimization techniques here, right? The comments get logged in the slow query, so that's another way to identify like if it is coming from specific code locations. So that's one way to identify where it is coming from. Next is to, when you write a query, use the explain plan against it. So the explain plan for queries will show you the query execution plan, how the optimizer decides what index are getting picked, if temporary tables are needed, how many rows are being parsed, that kind of thing. There also are other extended like extra options like explain extended and explain analyze. So go ahead and check those commands and use them whenever you're going to use a new query or you're understanding your query. Now, if you're running queries for analytics, they may take longer. but you do not really think that it can take 1 hour, 2 hour. Probably you just want to assuming that it should finish within 5 hours. uh, there is a way to control it, and it is using the optimizer hints. Max execution time, if you mention here, as you can see, I have included max execution time as a part of a query, and MySQL will ensure that the query will not run more than that specified number of milliseconds. Last 2 points. There's something that I see very often. One, do not include wildcards towards the left-hand side of a value in a string comparison. So if even if you have an index on that particular column, it will not be used. And same goes for the next comment that says, do not use functions. Do not use functions around the uh, column. So those are two things that are going to cause a poor query performances. So keep in mind those things. All right. Next place to identify the low-hanging fruits is replication. First thing first, replication is not a backup. Okay, one wrong query on the master, delete query on the master will destroy the data on the replica too. So that is that. In a multi-master replication setup, do not write on the both the nodes. It will create more problems than it will solve. So if you have data discrepancies on that particular instance, then it will become too complex to fix it. So it is wise to avoid it. A multi-master setup is better visualized as the active passive versus active standby setup. Oh, next is the configuration variable. I have specifically put it in the replication section because it says that slave row search algorithm, and as the name suggests, it searches it mentions the search algorithm that replica uses while executing the queries from the relay logs. As such, you do not need to worry about it if you are on MySQL 8 because it has been default to nice value. But if you are before that, consider changing it to index scan and hash scan. Okay, moving ahead. Make sure you keep your replica equally provisioned as master. It may have to serve as a standby, and it is also helps it to catch up on the replication. For replication lags, understand that replication is a single threaded process. So while master is accepting writes from multiple threads, replication only have one SQL thread to execute the changes and apply it on the replica. So if replication is lagging, consider parallel replication as one of the options. In parallel replication, or say multi-threaded replication, where we have multiple threads executing changes from the relay log in parallel. So the configuration decides based on the commit order or the write set how it needs to decide the parallelism of the transaction and apply in the parallel. There is a link here. Please go ahead and refer it for parallel application, but it is something that you should consider if your replicas are lagging. Next is consider using the delayed replica. A delayed replica is a replica configured to intentionally lag specific amount of time behind the primary instance. This way, in case of a human error on the master, it's very quick to recover it from the delayed replica rather than restoring from backup and then picking it up. And the final point, I want to make sure that the replication is having binary logs and log slave updates enabled. If you want to have a chain replication, like say you want to have additional replica under the present one, or if your node is a candidate master, then do not forget to make sure to ensure this variable, because like if primary is failure and you want to promote this particular server, then without binary logs and log slave updates, it's a problem, right? Okay, so that's for replication. Let's now talk a bit about backups. What are some of the low-hanging fruits in backup? What we need to consider here? To start with, do not backup on primary. Backups are heavy processes. They acquire some kind of locks, which may cause the connection spike on the server. For example, the backup locks on extra backup will not allow any DDL to pass through, and the queries following the definition languages are going to be waiting for that to finish. And this is also going to cause additional IO and thus impact the performance. Avoid backups on primary. Next is do not miss to check if your backup was successful or not. Like there are plenty of reasons why your backup may fail. Like it may fail because of the disk where you're storing the backup is full, because of a corruption, because someone else may have killed that process, probably because it is causing trouble. So make sure you get notified and take corrective actions to make sure you have backup processes taking regular backups. Third point, it is very important for backups, even more important than backups, and that is about restoration. So if you cannot restore a backup, and get the data in the form you want it, then the backups are useless. So make sure you make this as a standard practice to frequently verify your backups by restoring them and validating that whatever you're backing is exactly what you want to restore in case of a disaster. Last point on this slide says ensure the remote retention. So are you retaining your backup on the same machine? What if you lose that particular machine? You cannot have access to your backup, then you will not be able to restore. So ensure to retain your backups on the remote location. S3 and GCS buckets are like very common examples these days I see as a destination to retain your backups. Okay. Next is something with respect to business objectives, like verify your backup against the recovery time and recovery point objectives. Recovery time objective is the how you define the how fast you want to recover your backup from a disaster. And recovery point objective is something how much data loss is acceptable in case of disaster. For example, if your recovery time objective is 1 hour, your backup strategy is using MySQL dump, and your data size is 500 GB. You cannot recover 500 GB of data using MySQL dump. I really wonder, like, if you can. And then similarly, if your recovery point objective is say 5 minutes, you are only okay to lose 5 minutes worth of data in case of disaster, and you are not backing up the binary logs. Then that's not fair. So make sure you validate your RTO and RPO against your backup policies. So there's a very interesting video from my friend Pep here. Go ahead and watch it with respect to backup. Also, while we are talking about the low-hanging fruits of MySQL backup with respect to backups, I would mention 3 very common backup tools we use here and some of their properties. So MySQL dump, it is slow to backup and is slow to restore. It is very easy to run that, but it's like most commonly it's like because it's version independent, like it's a logical format, it's a logical backup in SQL format, so you can run it against most MySQL versions. Like if you take a backup of 5.5, you can run it on 5.7. I meant to say that way. But if you're using MySQL dump, ensure that you're using single transaction and make sure that you are aware of the options that you're running against using in your MySQL dump command. Like if you need to restore that backup for replica, then make sure you're using master data option. Next is extra backup. It is Percona's hot backup utility, which is fast option for physical backup and restore. But if you need to understand one thing, that if you have corruption on the file system level, the backup will also be corrupted, and usually this is true for all the physical backups. If you need to have logical backup and you need to have it fast, MySQL dump is something my dumper is something you can consider because it uses multiple threads to backup, and also my loader, the reciprocal command, will use multiple thread to restore the backup. Okay, moving on, let's talk about some of the Percona tools, some of the tools that helps us picking up the low-hanging fruits. I'm talking about Percona tools here. These are almost like 40 tools in Percona toolkit that makes our life easy in the day-to-day operations. I have just decided to list 6 of them. There are more of them that you can go ahead and refer to the link and learn about them. Let's quickly get to know them. So if you need to do table alters, like changes in change or like add a column in a table, add an index, change data type, defragment a table even. So PT online schema change is your key. It will allow you to perform these operations online without affecting your production traffic with minimal impact. PT kill, This command comes handy in case your application is gone crazy, having too many connections simultaneously firing up on your instance, and you need to control your database. ptkill can terminate these queries based on specified conditions. It can, like, you can mention which user, if you want to kill some queries from particular user, or if you want to kill queries that are running for a long period, so you can kill it that way. So that is your tool. Next is a combination of tools, that is to identify and fix the data discrepancies in a replicated environment. So let's say if you have duplicate key errors or data discrepancy identified in replication where master and replica has different data. So PT table checksum will identify that for you and pinpoint which database table, row, or columns are having difference of values on primary and replica. And the other tool, PT table sync, will allow you to safely seek the changes and ensure that the data in replica is consistent with the master. PT summary, PT MySQL summary, both tools come handy when you need to identify some of the system and MySQL related information in case you want to analyze them. PT Query Digest is another tool that I use to identify slow query. This tool is handy because it analyzes the queries from log, from process list, like slow logs, from process list, and also from the TCP dump. It produces a report along with the histogram, query runtimes. It records the processed or processed rows, return rows, and also includes the log time, etc. to number them in priority to the slowest, to like which needs the most attention to be improved. Finally, the duplicate key checker. It is the tool which we use to identify the duplicate indexes. Removing them will save some space, improves the write performance, and also creates the less confusion for optimizer to choose the correct index for the queries. All Percona tools are free and open source. You can easily get them by installing the Percona toolkit, and just it is also easy to fetch them. Like I just remembered, like percona.com/get/ the tool name. You can get that. Explore them from the link provided in the read link here. Moving ahead with another low-hanging fruit, and that is about off monitoring. If you do not see what's happening, you cannot fix it. So I suggest plucking this fruit by using PMM. PMM stands for Percona Monitoring and Management. This is an open source database monitoring and management and observability tool solution for MySQL, Postgres, MongoDB, PXE, Aurora, RDS. It also logs the information for proxy SQL if you have it in your environment. What it does, it allows you to observe the health of your database systems, explore the patterns, trends, and help troubleshoot the issue if you have it. I have included the links to the slides to explore PMM, to get the PMM, and how to install PMM in Ubuntu. Since this is well supported, documented, please go ahead and try it. Okay, let's move ahead and talk about the clouds. It's rainy season where I live here, but I will only talk about AWS today. So specifically RDS and Aurora. So what are the low-hanging fruits in Aurora Cloud? Note that do not leave default parameter group for your instance. So if you create an instance, it will have a default, let's say 5.7 or 8.0 parameter group. But if you want to change a particular parameter, it will not allow it. So you will have to make sure that you have a new parameter groups created for the individual cluster and database. It is important because this change also requires the instance reboot. So make sure when you create a new instance, have a dedicated options and parameter groups for that. Second is about HA in AWS. So if you're having a single database instance, consider enable multi-AZ, multi-availability zone instance for your instance. In multi-AZ setup, we have standby replica that provides the failover support and also helps backup. Like backups are taken on the secondary instance if it is there. So the performance on primary is not affected because of that. It does incur some costs, but that is something you need to decide based on your availability requirements, your HA and backup performance. Ensure that your log output is filed. Again, we already covered that, and also the next point about MyAsm we did cover because MyAsm is not supported in Aurora. For migrating to Aurora, there is a low-hanging fruit here that use extra backup. AWS allows you to use extra backup for spinning up new instances, and migration thus becomes very, very fast. A few things we shouldn't miss when you have your cluster or instances AWS is enable deletion protection, save to safeguard against accidental deletion, enable encryption, and also enable performance insights. Performance insights helps you navigate some of the system parameters, and it is free for 7 days of retention. Okay, let's say you run a delete query on a table and you missed a where clause, a delete from table, and there's no where clause. What is your option on the cloud? Well, you can do point in time restore, but that's something is going to take a lot of time because it's going to create a new cluster. So while recovery is going to take time, Aurora has a feature backtrack, which allows us to sort of undo the last command. So please go ahead and explore this backtrack feature and use that if you need, enable them if you need in your environment. Okay, conclusions. I have included, copied the very beginning, one of the 6th slide, I guess, here. So if you see why I'm including it, like there is a tomato as a low hanging fruit here. So let me just say the quote. The knowledge is knowing that tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. So the talk here is about knowledge sharing of what are the low hanging fruits of MySQL, which are quick to check and improve, which is based on my experiences in the environment I have been supporting. But I expect you to have the wisdom to use it wisely, test it before you go ahead and plug them in your production. All right, so if you have any questions, if you need help in your database architecture, feel free to reach us, reach out to me, reach out to Percona, even use Percona forums. The links are here. If you love open source technology, love the Percona blogs, content in them, if you're passionate about what you do or what we do, I invite you to apply for the appropriate position at Percona. Thank you.